All right, hey, let's do this. Hopefully the sound picks up good. So we're gonna talk about the comparison tests. Remember I told you we're gonna have one or two of these a day now? Yesterday we did the integral test, we did P-series, we talked about the harmonic series. Okay, we're starting to pile them up. So it's imperative that we start to be able to pick which strategy we're going to use, because the book will tell you most of the time. But I am going to throw 3 or 5 problems a day at you where you don't have direction in that manner. Okay, so you'll have to pick them. There are a few clues that we can pick up on. Okay, okay, the comparison test is the first one. It's assume that there exists an M, and it's a big capital M, greater than 0, such that that is true for the sequences. The sequences are A sub n is less than B sub n, or n greater than or equal to m. So we're going to see our partial sums are bigger than that number. In the series, B sub n converges. What do you think happens to A sub n? Converges or diverges?
Converges.
Why?
Because if B sub n is above A sub n and increasing, and it converges, and A sub n has to converge.
Right, exactly. B sub n is above it, it converges. So we know that A sub n below it has to converge as well. Okay, it's kind of the sandwich theorem. So, okay. If A sub n diverges, what do we know about B sub n? If A sub n diverges, what happens to B sub n? Anybody? A sub n is below, so if A sub n diverges, what has to happen to B sub n if it's above it? There we go. And so that's the comparison test. You're basically going to take the series that you have, create a new one above it, and show that it converges. Be careful. If B sub n diverges, do we know anything about A sub n? No, we don't. Okay, again, you've got the partial sums of B sub n diverging. Does that tell you anything about what's below it? A sub n. No, it does not. Okay, so again, the converse here, or the inverse, in fact, does not work. Remember, converses and inverses don't work. But this is the contrapositive of that statement. So, okay. Let's take a look at an example. Does this converge? Yes? How do you know that?
Because one over square root of n converges. Right? Doesn't it?
The P series at 1/2. No, okay. So not a bad thought. So here's the thought.
Oh,
Okay, correct? Right, because 3 to the n only makes the bottom bigger, which makes this smaller, correct? So you're gonna have to play with your fraction mindset here.
into the 1/2.
Make the bottom bigger, makes the fraction smaller. Or in this case, we made the bottom smaller, so this is gonna be bigger, right? Do we know that this is a P series, right?
He could be 1/2.
P is 1/2,
1/2.
n to the P, does that diverge?
Wait. Oh, because it's less than 1.
Yep. Okay, now does that tell us anything about this though? The bigger one diverges. Does that tell us anything? Okay, so doesn't help us, right? Sometimes that happens. Can you think of another one to compare this to? We want to keep it pretty darn close to the same. The top needs to be 1, just for fun, because that makes it really easy. The bottom needs to be a bigger number. Sorry, a smaller number so that this is bigger. Okay, this is a geometric series, correct? What is? And R is less than 1? Is that converge or diverge? Remember the R value is 1/3 here, right? Converge.
Oh.
Okay. So we can say that this in fact converges as well. Okay, so we just use the comparison test. Okay. This is bigger, it converges, so this has to converge to below it, right? Oftentimes, they're gonna bracket it in a geometric series or a P series or something of that nature. That's really easy to see the answer.
Wait, so what would R be if it's the Rn?
R is 1/3.
1/3?
Yeah, because you would rewrite it 1/3 at the end,
Oh, okay.
right?
Okay.
And C is 1,
Here's
and you'd have the series from n equals 1.
1. Okay.
So that would be your geometric series. That converges. Good. Here's another way to use it. Does series from n equals 2 to infinity, it's important, 1 over watch. That's 1/3, that fraction. So we're looking at this thinking, I don't know, right? This is n squared to the 1/3, correct? So 1 over n to the 2/3 is very similar P series, correct? Does that converge or diverge? It diverges, right? P is less than 1. So I'm kind of thinking this probably diverges, right? That's just my thought. So how could I show that? I would have to show something smaller than this diverges. I think it's something smaller than that.
You could do,
No, 1/n² is probably bigger
yeah,
because of that 1/3.
Right, the bottom will be bigger, which means that the overall series will be smaller.
Probably. So you guys are thinking, let's do this. Is that what you're thinking?
One over n squared be smaller.
Well,
you're square rooting that?
1, 2, and
Or-
Never mind.
2 squared is 4 plus 2 is 6. What's the cube root of 6?
In 1/4?
1/4. Okay, so that works, right? What about n equals 3? 9 plus 2 is 11. Cube root of 11. This is 9. This is a bigger bottom. This would actually be smaller. Oh, okay. So we had to think through that one, right?
We can't do that.
Okay, so this converges, right? B
Oh,
series, does that help us at all?
no.
No, it doesn't. Okay. Back to the old drawing board, as Wile E. Coyote would say. Right? Just after he gets blown up. What else?
So the rule is that the top diverges, it doesn't help, and if the bottom converges, it doesn't help.
Right. What about this one? We took a look at the harmonic series yesterday. Right? Does it converge or diverge? It diverges. It's in fact smaller than this. If this diverges, this then has to diverge. Okay. So two ways to show it. You can show something smaller diverges or something larger converges. And it will give you your result you're looking for. Okay. Be careful. Again, we already talked about this. So example 5. Is a good example of what I've already shown you a couple of times, of using the wrong function. Okay. In example 5, they compared it to 1/n. The 1/n diverges, so you can't say anything about it. So we've already talked about that, so I'm going to skip over it. Okay. All right, the limit comparison test. This is not on the BC exam. Okay? You will not be explicitly asked to use the limit comparison test. Now, if you're in BC next year, you might. They're actually adding it in next year. But this year, you will not be asked to use this test. But you can still use it. It's still a tool you can use. So I want to show it to you just in case you want to use it, because it is pretty handy. Okay. So A sub n and B sub n are positive sequences. And again, know those assumptions. Okay. Positive on this one. Okay. A sub n over B sub n gives you a limit, L. Right? We're just gonna stack them and take the limit as n approaches infinity. If L is greater than 0. So if you get a number bigger than 0 for your limit, then A sub n converges. If and only if, oh, I should probably write that out. You guys don't know if.
Yeah.
Do you know if?
Yeah.
No.
What was that, freshman year when you had to do all this stupid?
That's right, you guys actually took geometry with me.
Yeah, all those proofs.
Yeah.
Give proofs.
Now we're seeing the fruits of that, right?
Yeah.
Okay, so if you get a limit and you get a number, A sub n converges if and only if B sub n converges, so we're comparing the two of them. Okay. Now, if L is in infinity, that's an eraser, okay, thank you. Then what? I should write and there. A sub n converges, then B sub n converges. That was kind of a funky one. But it's basically what you're masking. This is the comparison test. Okay. So that's basically saying A sub n is infinitely bigger than B sub n, right? Because the limit's infinity.
Oh.
If A sub n is above it and it converges, guess what happens to B sub n? It converges as well. Okay, so A sub n is bigger and it converges, so does B sub n. That's the comparison test written a different way. Okay, that's basically what it's saying. Now, what's our last option? 1 and 0. Is that going to tell us anything? Yeah. B sub n converges, what happens to A sub n? It converges. Okay. So again, that would be very similar to the comparison test. The bottom is bigger. If it converges, we know the top converges as well, because it's smaller, right? We're thinking in terms of limits here. It's just another way to use the limit through the comparison test. The comparison test, generally, you're going to use something similar to a p-series or a geometric series in fraction form. Okay. This one can come with, become pretty handy with rational functions or those series as well. So let's show this series, n squared over n fourth. Show it converges. So actually give the answer, you just have to show it work. Yes. Generally, that's what you want to set A sub n equal to. That's generally. So. Is there a B sub n here that we could use? That's really, okay, really similar to this one, right? What's n squared over n to the fourth? 1 over n squared. Okay, do we know what 1 over n squared does? It's a P series that converges. So, we could use that possibly in the limit comparison test. That's the P series. P equals 2. So we can now solve our limit. So copy dot flip, right? One. Correct? Yeah, okay, so what does the test tell us? If it's greater than 0, that converges, and only if that converges, right? So what can we say about this series here? Yeah, so we can say that since okay, so that'll be the limit comparison test. Very similar to the comparison test. So we got one more and we'll be done. All right. Let's look at 1 over. Determine if that series converges. Yeah. Yep. So A sub n, and then B sub n is 1 over n. What is that? Convert that. Yeah, it's a divergence. So notice, is there any divergent language in that? So, but we can read into using our knowledge of theorems. Okay. If this happens, A sub n diverges if and only if B sub n diverges. That's legal. We can say that. Okay. What about this one? If L is infinity, B sub n diverges, then A sub n diverges. Okay, that's, you have to use this one. Go backwards, called the converse, the contrapositive. Right, and think about it. The top is bigger, right? Because L is infinity. The bottom diverges, what happens to what's above it? It diverges as well. Okay. So you kind of have to read into this one a little bit to get some of those divergent answers. Okay. So they can work. So let's try it. You're gonna get to the point where you just wanna write n over root n squared plus 4 on these, right? Writing it like that's kind of a pain in the butt every time. So if you want, you have my complete permission to start right here. Okay. I have no problem with that. And that is 1, correct? So since one over n diverges and L equals 1 or is greater than 0, this series must also diverge.
Oh, so when you put them together, it has to converge, prove that they diverge? Like, maybe it's n over,
Think, okay. This one diverges. Okay. This test is telling us that they go to the same, their limit they go to infinity, they go to the same spot.
so they both
So they
diverge.
both have to diverge.
Okay.
Does that make sense? That's kind of the general thinking of it.
If that didn't work, then you couldn't prove that they both diverge together.
If
Is the test working?
L would have been 0, we couldn't have said that.
Oh,
Because it doesn't work that if B sub n diverges, then A sub n diverges. That doesn't work. So now if A sub n diverges, then B sub n diverges works for this case. Okay, so remember, contrapositive, negative result, negative beginning, that's the contrapositive. That works. And that works here. The contrapositive. All right, so 2 more tests for you. They're both on your handout. Start plugging away at those and get some practice in on them. There are 3 or 5 problems on the homework that you are not given which test to use. You're gonna have to think through those. Okay, remember we have geometric series and P series. If they're basic like that, the harmonic series, and we got the comparison test, the limit comparison test, you have the integral test. Are there any others that we've done? The divergence test for sequences. Okay, that one works. The next ones we do, tomorrow we'll add the alternating series test. Then we'll add the ratio test, then we'll add the root test. Then, okay, you see how this is starting to pile up, so try to get these in your minds. All right, rest of the time's yours. Let me know if you have any questions.
what time is it?